Now in 17 we have taken some important examples and also previous year problem that is taken in 7th January 2020 mains. Now let us discuss 8/1/2020 JEE main 8/1/2020 shift 1 problem. The problem is 4 resistors, 15 ohms, 12 ohms, 4 ohms, 10 ohms. 4 resistors, 15 ohms, 12 ohms, 4 ohms and 10 ohms given in cyclic order. Cyclic order to form a Wheatstone bridge. What resistance in ohms should be connected? What resistance in ohms should be connected across 10 ohm resistor to balance the bridge. That is the question. 4 resistors, 15 ohms, 12 ohms, 4 ohms, 10 ohms given in cyclic order to form a Wheatstone bridge. What resistance in ohm should be connected across a 10 ohm resistor to balance the Wheatstone bridge? Now 4 resistors in cyclic order. So for bridge, okay, so this is P, Q, R, S. This is galvanometer. This is our EMF E. P, Q, R, S. 15 ohms, 12 ohms, 4 ohms, 10 ohms. These are connected in cyclic order. Okay. So bridges, no. What should be connected in and across 10 ohm resistance to balance the Wheatstone bridge? 15 by 10 is 15 by 3 by 2. This is 14 by 12 by 4 is 3. So bridge is not balanced. For the balancing the bridge, a resistance should be connected across 10 ohms. Let that be X. For the bridge to be balanced, a resistance should be connected across 10 ohms in parallel with 10 ohms. Now the bridge is balanced. Now for this the bridge to be balanced, what is the value of X? Now what is the effective now? This is, let us say, ABCD. What is RAD now? Effective resistance becomes R in parallel with X. This implies RAD is equals to Rx by R plus X. That is 10x by 10 plus X. 10x by 10 plus X. Now for the bridge to be balanced, what we have here? Therefore, this is, we are taking it as RAD now. So P by Q is equals to R by S. This implies P by Q 15 by 12 is equals to this one RAD. Here R means RAD by S. Plus 15 by 12 is equals to RAD is 10x by 10 plus X into S is 4 ohms. This is 4 3s, 3 5s, 5 2s. This becomes 10 plus X is equals to 10 plus X is equals to 2X. 10 plus, is it right? 4 3s, 3 5s, 5 2s. This is 2x is equals to 2x implies x is equals to 10 ohms. Implies X is equals to 10 ohms. Therefore, the resistance to be connected in is only 10 ohms. So this is the problem. This simple problem caching 4 marks. Very easy one. Therefore, for the bridge to be balanced, he asked what should be the resistance to be connected across 10 ohm resistance so that the bridge is balanced. Therefore, connect a resistance value of X across 10 ohm. Therefore, the parallel component becomes Rx by R plus X. Now P by Q is equals to R by S. That is one problem. Next one is in 8/1/2020. Next one is in same 8/1/2020 shift 2. Another problem was given. 8/1/2020 shift 2 JEE main. Shift 2. Another problem. Two batteries connected in series. Two batteries connected in series. Two batteries connected in series of same EMF 10 volts. Of same EMF 10 volts of internal resistances. Of 20 ohm and 5 ohm. 20 ohm and 5 ohm are connected to a load resistance. Are connected to a load resistance. Are connected to a load resistance of 30 ohms. Of 30 ohms. Now an unknown resistance X is connected. Now an unknown resistance X is connected in parallel to the load resistance. In parallel to load resistance. In parallel to load resistance. Now find X so that the potential drop of battery having internal resistance 20 ohms. Internal resistance 20 ohms is 0, becomes 0. Very good question. So two batteries connected in series of same EMF 10 volts. Two batteries connected in series of same EMF 10 volts, plus minus because this is in series, no, therefore positive negative only, positive negative 10 volts each of internal resistance 20 ohms and 5 ohms are connected to a load resistance of 30 ohms. This is 30 ohms. Now an unknown resistance X is connected in parallel to the load resistance. Unknown resistance X is connected in parallel to the load resistance. So that the find X so that the potential drop. Find X so that the potential drop of the battery having internal resistance 20 becomes 0. So if the drop across this one is 0, potential drop is 0 for this one, then what is the X? For PD of 20 ohm is equal to 0, X is equals to how much he is asking. Now for this one, let us take this one as E1, this is R1, this is E2, this is R2. Okay, let us this one as R. Now what is potential drawback of first battery? V1 is equals to E1 minus IR1. Let the current is high here. The current is high. V1 is equals to E1 minus IR1. We know this implies what is asking? The potential drop of battery having internal resistance 20 ohms becomes 0. Therefore 0 is equals to 20 ohms is 0. V is equal to 0 for 20 ohms. 0 is equal to E1 is how much? 10 minus I into R1 is 20. This implies 10 is equals to 20I implies I is equals to 10 by 20, that is 0.5 amps. Therefore, the current I we got it as 0.5 amps. I is equals to 0.5 amps. Now, what is V2 now? V2 is the same current flows. Same current flows. Therefore, V2 is equals to E2 minus IR2. E2 minus IR, that is equals to E2 is again 10. E2 is again 10 minus I is 0.5 into R2 is again 5. That is equals to 10 minus 2.5, that is 7.5 volts. That is 7.5. Therefore, the total potential here is 0.75 volts because this is 0, this is 7.5. Total potential is 7. Net potential V is equals to V1 plus V2, 0 plus 7.5, that is 7.5 volts only. Now we are having something like here the potential is 7.5 and the resistance R like this and also X like this, X and R. R is 30, this is 30, no? This is 30. The current is I, the current is 0.5. This is volts, this is amps. What is the effective resistance? 30 and 30 in parallel with X implies R effective is equals to, R equivalent is equals to 30 into X by 30 plus X. This becomes like this now. 30X by 30 plus X. And this is 7.5 volts. The current is 0.5 amperes. Now what is V now? Now what is V? V is equals to now V is equals to IR. This implies V is equals to V is 7.5 is equals to I is 0.5 into R equivalent. R equivalent is equals to 30X by 30 plus X. 30X by 30 plus X. Now 0.5 5 ones 15 times. 0.5 15 times 15 2 times implies 2X is equals to 30 plus X. 2X is equals to 30 plus X. This implies X is equals to 30 ohms. X is equals to 30 ohms. So that is the another problem. Very important one, very good problem. So this is, he has given that, he has given two EMFs. Two batteries are connected in series. Therefore, positive, negative only. Connected in series of same EMF 10 volts and 10 volts. E1 is equal to 10 volts. E2 is equals to 10 volts. Of internal resistances 20 and 5. 20 and 5. R1 20, R2 5. Are connected a load resistance of 30 ohms. Load resistance of 30. Load means complete output is called as load. 30 ohms. Now an unknown resistance X is connected in parallel to the load resistance. Unknown resistance X is connected in parallel to the load resistance. Find X. Find this value of X out of the PD of battery having internal resistance 20 ohms becomes 0. This PD is, this V1 is becoming 0. Therefore, what is V1? We know that V is equals to E1 minus IR1. V1 is called as terminal potential or terminal voltage and IR1 is called as last voltage. I told you these things in the previous classes. What is terminal potential? What is last voltage? We discussed this. Therefore, V1 is equals to E1 minus IR1. This is the available EMF. Available EMF is equals to V1. Therefore, 0 is equals to, we are given, like if we put R1 is equal to 20, then V1 should be equal to 0 because given that here given that potential having potential interrelations 20 is 0. Therefore, 0 is equal to 10 minus IR, I into 20. Therefore, we get I is equal to 0.5 amps. Now, V2 is equals to E2 minus IR2. V2 is equals to E2 minus IR2. Therefore, that becomes 10 minus 0.5 into 5. 10 minus 2.37.5. Now, what is total potential across these terminals? Net potential is 0 plus 7.5. 7.5. Now, what is the resistance parallel to that one? 30x by 30 plus x. Now, what is V? V is equals to I into R equivalent. Put the V is equal to 7.5. I is equal to 0.5. R equivalent is equals to R equivalent is equal to 30x, 30 plus x. Put the value, we get x is equals to 30. These are the two important models. Let us discuss another model in the next class. Okay.